Hi everyone. In this video we're going to look at an example of graphing a quadratic function, and we're going to graph one that's given to us in intercept or factored form. As a general reminder, remember that zeros, roots, x-intercepts, and solutions, all four of those words are similar in meaning. The main reason we call this intercept or factored form is because factored form, obviously because it's factored, but intercept form because it's really easy to find what the x-intercepts or zeros are. By applying the zero product rule straight up from here, I can just set the factors 5x minus 3 equal to 0, and also set the factor 5x plus 17 equals to 0. After solving, we come up with x equals 3/5 and x equals negative 17/5 as our two zeros. One comment I want to make to help us be able to see which way the parabola is pointing, whether it's pointing upwards or downwards, and also to be able to really easily see a vertical stretch or compression factor, is I could take any coefficients in front of the x inside the factors and I can factor them out. Since each factor has a 5 in front of the x, I'm going to factor the 5 out of both of those. Pause the video for a sec and figure out what should be left inside the parentheses if I factor out a 5. After factoring, you should see that in order to distribute the 5 back to get what you originally had in each factor, you would need to have x minus 3/5 in the first factor and x plus 17/5 in the second factor. By rearranging the two 5s, we can really easily see the vertical stretch factor of 25, the reflection over the x-axis, and it's now even more obvious that our zeros are at positive 3/5 and negative 17/5. Next, we're going to find the axis of symmetry. I can either do this with my formula by adding up 3/5 and negative 17/5 and then dividing by 2, which gives me an axis of symmetry at x equals negative 7/5. I could also visually look at the zeros, in which case it would probably be a lot easier to represent negative 17/5 as negative 3 and 2/5, which means that halfway in between is going to be negative 7/5, or it might be easier to represent it here as negative 1 and 2/5. Now I need to find the minimum or maximum value. As we saw at the beginning of the problem, the parabola is reflected over the x-axis, so it's going to be pointing this way, which means that it's going to have a maximum value. To find the maximum, I need to find f of negative 7/5, which I do by substituting negative 7/5 in for the x. So 5 times negative 7/5 is negative 35/5, which would be negative 7, which applies to both factors in this case. So negative 7 minus 3 is negative 10, and negative 7 plus 17 is positive 10. So when I do negative 10 times positive 10, I get negative 100, and then the opposite of that would be 100. All that's left to do now is actually draw the parabola. Once again, when actually drawing your graph, it might be a lot more useful to represent the fractions as mixed numbers. So I have my axis of symmetry at x equals negative 7/5 or x equals negative 1 2/5. I also have my two zeros at negative 17/5, otherwise known as negative 3 2/5, and also negative 3/5. If I have the vertex, and then I have my two zeros, I have 3 points, which is enough to give me a good picture of what the parabola looks like. So in summary, if the parabola is given to us in intercept or factored form, first I want to find the zeros using the zero product rule. Second, find the axis of symmetry, either visually or by adding up the two zeros and dividing the result by 2. Then I find the minimum or maximum value by inputting the x value for the axis of symmetry into the function and finding what the y value is. And then finally I plot the vertex on the axis of symmetry and I draw the parabola using the vertex and using the two zeros as the 3 points that determine it.